JDT. The agenda for the hour. We're going to talk about what Java 9 and Project Jigsaw is all about. I mean, everybody's been talking about the Project Jigsaw. So we'll find out, at least just to make sure that everybody's on the same page, we'll find out what it is all about and what modules mean to Eclipse and Eclipse projects. And I'll also tell you a little bit about converting your existing projects into Java modules. We'll also see how we can use Eclipse IDE to create, build, and maintain Java modules, and a little bit more in terms of stories and discussion points and all that. So the Project Jigsaw, or the Java 9 actually contains the Project Jigsaw, which is the most important aspect of the Java 9. It comprises the modular JDK, modular platform source code, and it also has support for Unicode 7 and 8. There are a bunch of little things combined into middling project coin, which is the JEP 213 is about, and then there's the new version string scheme, which the JEP 223 talks about. So the Java 9 is slightly different from the previous releases of Java we had before. So usually, like in case of Java 8 or 7, the changes that come in are in terms of the APIs, new APIs or API changes, and then in terms of the Java language specifications. So where we are different here is that the Project Jigsaw completely revamps the whole compiler system. So it introduces something called Java Platform Module Systems. In the old Java 8 world, we only had something called class paths, right? So you put jar files into your class path, and once you put all sort of things into your class path, the compiler can get whatever it wants from the class path. Of course, there were rules in terms of visibilities, like package visibility and all that, but that's going to change with Java 9. And the modular JDK is going to, the goal is that the whole JDK is going to be modularized, and you would be able to pick modules from, whatever the JDK has. You can just pick modules and build your own platforms. So you don't really have to just take the whole Java standard edition and use it to run your applications. You can just take a small part of it, only the portion that your application needs, and bundle it with your application, and so that makes sure that your application footprint is much smaller than what used to be. Even the platform source code, like what you like java.lang.object or java.sql or Java XML, so all sort of things, they have been modularized. So which means that you only need to worry about the code that you are interested in, right? If you're not going to use database connections, for instance, right? You don't need the java.sql module at all. So you can safely leave that out from your source code as well as from your application that is going to be bundled up. There's a lot of details going into the Java platform module systems. We will talk some of those things about in the coming slides. The other important change is that the modular runtime images. So the biggest change is that we will not have jar files as part of the platform. If you have ever opened the JDK or JIE, you would have noticed that there are a bunch of jar files that contain the system libraries, like rt.jar, that would contain all the basic system classes like object, string buffer, and all that. So they are being moved into a different format, and so when we started, we had a couple of JImage files, and at some point it changed to individual JMod files for each module, but then the specification does not say anything about the format of format in which the system libraries are going to be stored. So what instead they do is they have introduced a brand new URI scheme which is called Java Runtime JRT. And fortunately for us, the JDK 9 and is actually bundled with an implementation for this file system, the java.nio based file system. So I believe this is going to be shipped with the more recent versions of JDK, and of course it will be part of the JDK 9 and JI9 as well. The other change is that they have gotten rid of the boot class path and the extension directories, so the compiler has to account for those as well. So we talked about the module system libraries, right? So here's a comparison. On the right is a Java 8 project that contains Java JDK 1.8 in its build path, and if you had ever expanded the system library in your Project Explorer, you would see that you have a bunch of jar files. And what you have on the left is how it's going to look in the Java JDK 9. So what you have is the bunch of modules that the system contains. So Java.base is what will have all the basic things, and all the specialization modules will specialization code will go into their own module. So this is a big difference, at least for the compiler implementations. So like I said, in the past you had to look at just whatever class path you are given. You just had to look at all the jar files one after another and look for files that you need when you're compiling a Java file. That's going to change. That's going to change because you will only need to look at the modules that your program needs. We'll look at it in the coming slides. So what exactly is a Java module, right? According to the definition, it's a named Java entity that will be self-describing, and it will contain all the code and resources that your module will need. The goals are that it offers reliable configuration, and it strongly encapsulates whatever you put in your module. And on the right you have a simple module descriptor. As you can see, it exports a bunch of packages to optionally to target modules, and it can depend on other modules. In this case, it requires java.base and java.sql. And obviously this looks familiar because this is almost like the OJ, whatever the manifest files you have, you put in your bundles, right? So just that the syntax has changed. So it's not for me to tell what's going to happen with respect to the OJ bundles, but it certainly sounds a lot familiar with what we've been using all along. So where does module fit in an Eclipse project, right? So again, I have the same example, typical Java 8 project. In JDT terms, we have class path entries, and then we have package fragment routes. So class path entries are nothing but typically they are the jar files and source folders. And all of this, actually, the class path entries and the source folders would become your package fragment routes. A package fragment route is nothing but any physical location or virtual location, I mean, in case of jar file, that can have a default package, right? So in Java 9, each class path entry is a potential module. Of course, except the system library, because system library would contribute multiple modules. So there was a lot of debate about what we wanted a module to be in Eclipse, where does it fit? Whether it's going back to this, whether we have this two source folders, r.abc and then r.abc.test. So one can imagine that both these source folders can become respective modules. So that's one of the options we talked about, and the other option is, of course, that each project becomes a module. So those two were the options that were deliberated on. There was a lot of discussion, debate, and there were people taking each side. Um, there were actually pros and cons for both approaches. Obviously, with respect to having multiple modules in a Java project, it really gives you a lot of flexibility. You can have uh, your source module and your test module in the same Java project. And of course, the command line compiler is supposed to support that as well, and so that way we will be consistent between the command line compiler and the IDE. The challenges are that discoverability. I mean, if you want to uh, if you want to put modules in each source folder, and just imagine that you have two modules with the same name, that's going to become really difficult. Whereas in case of if you make a project a module, Eclipse already takes care of that. You cannot have two projects with the same name in a workspace, so that's already taken care of. And um, then again, what happens in case of one? Even if you want to convert an existing an Eclipse or OSG bundle into a module, we're really out of options. I mean, we cannot really take that and convert into a module. Obviously, it complicates the setup bit, and so what happened was that we went with the one project, one module approach, and obviously there's people who are not really happy about it, but I guess this is the uh, approach that would not break many clients. So which means that so even if you have multiple source folders in a module, only one of them can have a module description file. So you get to decide which one that is, and even if you have multiple, even if you try to put multiple module descriptions, Eclipse is going to complain that you cannot have that. So if you're interested in the details, you can just look at this bug for all the discussions we had on that. So let's see. So like I said, this is a really different version of Java 9. We had to change a lot of things. So it's just not about the Java language specification. So the compiler had to change the way it looked for class files. Like it had to it had to look away from the jar files. It had to look at the JRT. It had to implement the JRT specification. It also had to impose a lot of rules in terms of visibilities and all that. So that required a lot of effort in terms of the compiler. The module info file, right? It introduces a new syntax and keyword, so that required some effort in terms of the syntax highlighting, formatting, and of course the assistance in terms of code completion and the navigation. So that required some effort. And last but not the least, Milling project coin, that is just a bunch of language changes that we implemented. With that, we'll do a quick demo on what we have. So what I have is the latest Y-build. So you would probably have seen the I-build, M-build, and all that. So this is we call it Y-build because it's not public. It's so whatever code we develop for Java 9 support, that goes into a separate branch. So this of that branch we produce builds that we consume, and of course if people are interested, they can try them out as well. Um, So I'm going to just show you what it takes to um, just try out the new build. This is actually not going to run off the shelf, but I'll just to demonstrate, just try and run it. So that crashed. That crashed because the JDK 9. I'm actually trying to run it. I mean, if you see this, I'm trying to run with the JDK 9. So Eclipse would have happily run with the JDK 8 or J8, but it's not going to happen with JDK 9 because it required some special attributes uh, to be able to run with this version. So I have that thing here. So these are the couple of I hopefully temporary JVM arguments that you have to pass. Things have actually changed. I mean, this all system was used to be something else, and now it's become all system. So it's kind of in a flux state. So I would say it's likely to change again. It probably might go away altogether, but we will have to wait and see. So these are the couple of things that you need to make Eclipse this particular version of Eclipse run with JDK 9. So I'm going to run it again now. So it seems to be running all right. All right. So in the interest of time, I have a bunch of projects in my workspace, and but what you see here is a typical Java 8 project, and it has JDK 8 in its build path. So I can show you that. All it does is just a couple of packages and some a couple of classes. So nothing special about this. I'll show you how you can take this project and convert it into a module. So first thing you need to do is obviously you have to change the build path to have the JDK 9. I'll do that first. And the next step is to move the project's compliance level to 1.9 if it isn't already. It's already on compliance 9, so that's fine. So you right click on the project and so configure and create a module info. So this creates the module descriptor for you. As you can see here, it just lists all the packages, non-empty packages, and puts them in the exports clause, and also the compiler knows that you are using referencing classes from all the three modules here: Java.base, desktop, and SQL. Actually, if you don't believe me, you can just go ahead and look at this. So I am using this particular class. It's actually coming from Java.desktop, and this uses the Java.SQL module. So all that information is put in this one. At this stage, it only it. I mean, you can probably say that it doesn't do a lot of things. Like for instance, it doesn't fill the users and provides clauses, but they're certainly on the cards. Certainly, we would look at providing those things as well in the future. Um, so now that this is being converted into a module. I'm going to go ahead and make some changes to demonstrate some of the capabilities we have added to the compiler. So I have two other projects which are already module. So you can see that I have some modules there already, a couple of modules to be precise. So I'm going to create some dependencies. I'm going to say module A depends on module B and C. Right? Actually, at the beginning of the talk, I mentioned that you could create your compact profiles, right? So I could actually show you one trick how you can do this. I mean, so there is, for instance, there is a I don't really know the term for that. For instance, they have some container modules. I mean, they don't really contain any code. All they have is they just references a bunch of modules. So, for instance, the java.se is one of them. So instead of referencing three modules here, all I can do is I can just say, okay, actually to demonstrate that I will comment this out, and so you see that there's a problem there. Obviously, I need these modules, but I'm not going to reference each module individually. So I will just say, as you can see, the code completion, all that works. That's it. So basically, this java.se replaces all the other module dependencies you had. Um, of course, what we really wanted to do was that we wanted to add dependencies to module B and C, right? All right. Um, you cannot see modules B and C. So traditionally, if you want uh, if you want one of your projects to references something from another project, the only way you could do is creating project dependencies. But it's not really fair to expect the user to do that, right? I mean, so if he does it, then he would be defining the dependencies in two different places. So obviously you have the required clause in the model info file, and you cannot expect the user to go and change the build path as well. So we have something called uh, the module container. Unfortunately, at this point, it's you have to manually add it to the class path, but eventually this should be automated. So what it does, all the compilation errors have gone, and so basically what it does is it just the container is responsible for looking up all the modules from your workspace. So in the Java 8 world, you would have actually you would have expected to uh, add both B and C to the build path, whereas in this case, all I did was just added the module container to its build path. So it takes care of looking up all the modules from the workspace and making sure that they are visible uh, to the depending module. So that works nice and clean. Similarly, you can have obviously modules coming from jar files as well. So, right, I have a couple of jar files added to the build path here. Um, you could just very well add them to the build path, and uh, uh, define the dependencies in your module info file. And so another thing I would like to mention is that if you see this one, right. So module B defines the transitive dependencies on module C. So which means that any module that depends on module B will actually get to see module C as well. So so you know that I'm going to this thing, and just let's see what we have in the module here. So I have this class, right? So ouch. All right, that has to be the demo got playing with me. So, um, so anyway, coming back to the presentation. Uh, so we have the JSR 199 implementation. Of course, it's not tested, and I believe the community hasn't really started doing enough with respect to testing the builds that we've been producing. And the command line compiler works all right, and it needs support in terms of the new options that have been introduced as part of the specification. Outline view could need some help. Annotation processing is in the works. It's all in progress, and hopefully in the next month or so we should have these features completed. So some of the things that we are not sure we're going to provide, but it all depends on what the community wants from us. So there might be some support for creation of the JMod files, and just link with the JLink tool from the JDK. So it's all on the cards. So the next 1 or 2 months should tell us where we're going. So there is still some discussions going on. So for instance, what is going to be the scope for the features like search and code completion and all that, right? So should it have the same scope as is defined in the model info file, or should it have the broader scope? For instance, right, my model info only references java.base, and in my program I want to complete a code. I want to reference a code java.sql.connection. Should the editor provide me support for that? So some I would say so. I would certainly so. So those are things that we are still discussing. And so what happens to the redundancies of information between the manifest file and the model info file? So there's that's also another point that we would like to conclude at some point. So restricted keywords and split packages, these are the two topics that have been hot. There's been a lot of discussions actually going on. Just to give you some idea about what restricted keyword is all about. So this is a perfectly legal and valid model description, right? All the just for your understanding, I have put all the keywords in red and all the names or identifiers in black. So the specification, the Java lang specification uh, uh, has mentioned that the keywords, the new keywords, the module related keywords, are only keywords when they appear where they're meant to be, right? And it's perfectly possible to have a module by the name module, and you can have a module by the name required. All the keywords can continue to be valid identifiers. And our parser really had a tough time. I mean, so if you just look at the second statement, right, exports to exports. So what it means is this particular module exporting a package to the module exports. But just looking at just scanning one token at a time, you cannot possibly understand what the code is actually all about until you hit the semicolon. You have absolutely no clue on what the statement is all about. So there were several ideas discussed. One of the options was that we would use um, escape characters to differentiate the the keywords from identifiers. Then annotation was also another option that was mentioned. Eventually, whatever we're looking at here, that would stay. So the tool implementers like us will have to deal with it, but that's the way it is. Split packages, right? So this this idea was non-existent in Java 8 world, right? Uh, you can actually have multiple, you can have multiple jar files containing the same packages in Java 8. But it's a simple case of first come, first serve. So whichever, so if the compiler finds a particular package in a jar A, it's going to take that package from there. It, even if that package is defined in another jar files, the compiler is not bothered about. But it's not going to be as simple as that with respect to the modules. So modules also can have packages of the same name. Multiple models can have the packages of the same name. For instance, the Java in Java. I think I guess I meant Java base. Both these modules have the same package, but the compiler is not going to look at them as the same package. They are actually different because they could really define how the compiler what the compiler sees actually depends on the module that I'm trying to compile. For instance, the rule is that any module you're trying to compile cannot see the same package from two of the modules that it depends on. So that's the rule. So that's something that we're still working on, and like I said, the specification is still being worked on, and fortunately, just a couple of weeks back, we got some updates in terms of the specifications which we're waiting for. We're working on it, and hopefully, in a month or so, we should have all the corner cases handled. So if you really want to try out, creating modules and all that, so you have two options. One, you could take our feature patch, which is based on Oxygen, or you can take the same one for the marketplace as well. Or we have the weekly builds, which is the one I'm using. The whole SDK is built from the branch I mentioned earlier. So you could use one of these options and get started. So please evaluate the sessions whenever we have time, and I would like to draw your attention to the Eclipse Summit India 2017, which is coming up on July 29th. This is the second edition of the event. It would be nice to have some people. You can. I guess it's a bit late to propose talks, but it will be nice to have people visiting the conference there as well. So that's all from me. Thank you very much. And if you have any questions, please. Yeah. So, sorry, I didn't get that question.
So, simple question. If there are no more jars in Java 9, what about backward compatibility? For example, I want to use a Java 6 project in a Java 9 project. How do I do that?
Can you hear that? I mean, I'm sorry. I'm not sure I got the question right.
So, for example, today, I have a Java 8 project using a library that was compiled with Java 6, and it does work. So what about Java 9 if there is no more jar? Because the Java 6 project is compiled in a jar.
Okay. Just because the JDK doesn't ship in jar files, it doesn't mean that we cannot have jar files. We can continue to have jar files. So you have two options. So I obviously didn't want to get into the details, but there are these terms called unnamed modules and automatic modules. So whatever you have, the legacy code you have in your jar files, that would be called unnamed modules. And there are certain rules about what a named module can see, and how other modules can see unnamed modules, but you can continue to use those jar files definitely. And there is also the term called automatic module. If you want This is actually one of the migration options that the Jigsaw team has put together. So you can actually mention that this jar file, I'm going to make it. Obviously, you cannot change the source code and rebuild and all that. So what you do is you just put that jar file in the build path, and that becomes an automatic module. And so when an automatic module gets its name from the file name actually. So it doesn't have a module description, but the compiler gives the module its name from the jar file's name. So what you can do is your code. Now, let's say you have some code that's in your control. So you can actually say, so let's say the jar file's name is lib1.jar or something like that, right? So you put it in the module path, and then you go back to your module description file and say requires lib1. So that's how you take an existing jar file and convert that into a module and use it in your other modules.
Okay. Thank you.
Hi. Could you tell us more about the recent vote by IBM and Red Hat? The no vote for JPMS to go beyond the public review stage, and whether actually some of those reasons were the discussion topics that are still being discussed, and then whether you think this is going to further delay Java 9, or whether Oracle is just going to go on with it.
Okay, so I cannot, even though I'm from IBM, I cannot speak for the IBM's vote. What I can speak for is the Eclipse vote, right? So Eclipse also is a contributor participation. Yes, some of the factors actually did have an impact on our work, and so some of the discussion points I mentioned, right? The keywords and the split package. So those were some of the hot topics that it probably had some impact on the voting process, and but that's in the past, and I believe they almost, it's been a month since then, right? And so the next vote is up, and hopefully we would have, I mean, at least as far as the Eclipse team is concerned, we are happy with the progress that we've seen in terms of the specification. So I believe we're good to go. Yes. So when I started, I was actually trying to get some figures, but so there were actually a couple of factors that impacted. So one is that, okay, so the only way we could actually, only factor that would impact the compilation time is that we don't read from the jar files, and we read from the JMage files. And so there are two things, right? So one, it's not not so much in our control. And so whatever cache, so we had some caching mechanisms in for the Java 8 related things. We would cache the jar files and contents. So that's all gone now, and we are at the mercy of the JRT implementation that JDK provides. But whatever tests I ran didn't really show any regression, neither did it show any improvement. So at this point, it's too early to talk about, and we're not at this point where we can actually talking about performance. At least what I can guarantee you is that there is nothing significant that's going to change.
One last question for me about the modules in Java that we may need or not. I think about your example where you said I need 3 modules, and finally I say I need java.se. So will there be any help, for example, in Eclipse, to know exactly which modules I effectively need in my project and not just java.se?
That's a really good question, actually. At this point, I hadn't thought about it, but it's certainly not impossible to come up with something like that. And we'd be actually happy to have a bug on that, so we can go back and take a look at it. All right. Thank you very much.